What's up, pre-calculus students? Mr. Messner. We are graphing some rational equations based on some characteristics. Obviously, you can do this with a calculator. Obviously, there's a lot of people out there who are not doing what they're supposed to be doing and still getting good grades, and it's like, all right, good for them. But moving forward, it's not really going to help them. So here we go. We're going to do it. We're going to do everything pretending like we don't have a calculator. We could use our calculator to check. I don't know, whatever order you want to go in, this is what we have to figure out. We got to figure out our x-intercepts. We got to figure out our y-intercept. We got to figure out our vertical asymptotes. We got to figure out what our horizontal asymptotes are. We got to figure out any holes, if there's a location of the hole. And we should figure out when we're positive or negative. We need to do kind of a sine analysis to figure out what's going on where. Okay. So what order do you want to take it in? I don't know. Let's just go straight down. Actually, let me do the easiest one. Y-intercept. It's when x is 0. Plug in 0 everywhere, you get 0. Okay, you get 0. F of 0 is 0 over negative 2. So that's 0. So I know I have the point 0, 0. Cool. That's also an x-intercept. X-intercept you find by factoring. And you got to look at the numerator equal to 0. And might as well factor the denominator. Denominator factored is x plus 2, x minus 1. The numerator factored ends up being x plus 3, x minus 1. So this is what I got. All right, so like looking for zeros. Remember, vertical asymptote occurs when you have a number over 0, a hole when you have 0 over 0. X-intercept is when you have a 0 over a number, okay? When x is 0. So I'm going to have a hole. So maybe it's easiest to do this all at once. A hole at x equals 1, because I'd have 0 over 0. I'd have a vertical asymptote at x equals negative 2. And I have an x-intercept at 0. Already found 0, 0, but also at negative 3. So what can I do? I can plug in negative 3, 0, boom, I got x equals negative 2. Okay, that's a vertical asymptote. And I got a hole. Let's find the location of the hole. How do you find the location of the hole? Well, you can't plug in 1 into this because you get 0 over 0. But like this and this will end up canceling each other all the time whenever you plug in a number. So what if I plugged in 1 now? I can plug in 1 now. I got 1 times 4 over 3. So 1 comma 4 thirds is location. So 1 comma 3 thirds, 4 thirds would be like right there. Let's look at the horizontal asymptotes. This is when we're looking at x approaches infinity and negative infinity. So for the horizontal asymptote, I can ignore all the stuff that doesn't grow fast as the fastest growing term. So I got x cubed over x squared. And then what I like to do is simplify that. That simplifies to just be x. All right, well then, if I plug in something like positive infinity, as x goes to positive infinity, my y's or my f of x obviously is going to go towards positive infinity. This is just positive infinity if I plug in positive infinity. And as x goes to negative infinity, I'm going to go towards negative infinity. So there's no horizontal asymptote, but this is like the end behavior. All right, so I'll be like down here, and I'll be up here. Now I'm ready to graph. Before I do that, I want to make sure I got some signs kind of taken care of. So let's do what we did earlier with inequalities and plop down these interesting points, negative 3, negative 2, and 0, and check some signs. We'll check it in this version. And so I plug in 1, positive, 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 positive. At 0, I have an x-intercept, so most likely I'm going to change signs at 0. So at negative 1, let's see, negative, positive, Negative 1 minus 1 is negative 2. Hold on, I got all screwed up. It should be positive 1. Hole's at a location of 1. Hold on. I should be going 2. I plugged in 2. Positive, 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 positive. If I plug in a half, positive, positive, negative, positive, negative. That's still a positive. Also, I messed up. The hole's location, to make sure we know what a hole is, you got to put an open circle. It's like there's no point there, but this is the location of where it is. Okay? All right. Now, at 0, if I plug in negative 1, negative, positive, negative. Okay, so let me just write this down. Negative, positive, negative. And then this is positive, negative. All right, so these are going to be positive in the numerator. The denominator is going to be negative, so boom, I have a sign change. Okay, then at negative 2.5, I'll have a negative, positive, negative, negative, negative. Okay, negative, positive, negative, negative, negative. This is a positive, this is a positive. These are going to be positives. I do change sign. At negative 3, which is an x-intercept, I will change sign as well. You can kind of look at the multiplicities again to figure that out. So negative 4, negative, 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 everything's negative. You'd end up with a negative in the numerator and a positive in the denominator. So this is going to be negative. Now, what's that tell me? Okay, well, that kind of confirms here. We got negative, I'm going to pass through negative 3, and then we're going to be going to positive values, trending towards this asymptote. I hit the asymptote at negative 2, and I switch to negative values. So I'm back down here at negative values. And again, a situation like plugging in something very, very close to negative 2 is going to give you like a number divided by something very, very small and either positive or negative. And this is kind of confirming that it's going to be negative. I'm going to travel through the point 0, 0. I have a hole at this location, and then traveling towards infinity, something like that. Is it going to look exactly like that? No, but this is all you need to do. Now, what we would probably ask you to do is not graph for a quiz or something, but instead we'd ask you for locations of characteristics and stuff like that. If you have a calculator, if you have Desmos, you can obviously check. And it's good to check. It's not good to just use it and just not learn anything, which a lot of my students in my class are doing. It's cheating. X cubed divided. There you go. X cubed. There you go. And the numerator, x cubed plus 2x squared. Stay up there. Minus 3x over x squared plus x minus 2. Okay, so it's just what I have. Boom up, and then passing through a hole at 1. What's that location? 4/3, 1 1/3. All right, let's look at number 2. Want a factor, but gosh, why do I have to have a 2x squared in the numerator? Oh, let's factor the denominator at least. I got x minus 4, x plus 2. In the numerator, let's see. It's going to be 2x and x. It's got to be like 4 and 3 or 6 and 2. So you get negative 12 and 4. That's not it. I got 4. No. I think it's 4 and 3. I'm going to use the cheating method. X squared minus 5x. I'm going to multiply a by c and get negative 24. 8 and 3 are the numbers, so that means I can go back and rewrite this as negative 8x plus 3x I can factor this by grouping. That's not right. Oh, this isn't 24, this is 12. There's other techniques out there. So this is 2x plus 3x minus 4. Hey, I'm recording a video right now. Do you want to just watch? And we'll have questions at the end. Okay, cool. So, what do I need to do? My characteristics are my x-intercept, my y-intercept, my vertical asymptotes, my holes, my horizontal asymptotes, and then let's do a sine analysis. So my factored form gives me some zeros. I can see I'd have 0 over 0 when x is 4, so my hole's located at x equals 4. I got -2 in a denominator would make the denominator 0, so a number divided by 0, vertical asymptote, x equals -2 is a vertical asymptote, just like my last one. Look at that. I have an x-intercept at -3/2. That's when 2x plus 3 equals 0, so -1.5. My y-intercept is when x is 0. If I plug in 0 into this function g, g of 0 is -12 over -8. -12 over -8 is positive 3/2. So I got the 0.3, 1.5. I got an x-intercept at -1.5. I have a vertical asymptote at -2. I got a hole at 4. Where's the location of the hole? Pretend like it doesn't exist. Plug in 4. You get 8 plus 3, which is 11 over 6. So that's almost like 2. So 4 comma 11, 6 is almost 2. Horizontal asymptote. No, it actually works out. Horizontal asymptote as x approaches infinity. Well, go back to the original function. If you're plugging in infinity, all the other stuff besides the highest degree term is going to make no difference. It's going to be like adding a small decimal to a very large number. So we're really looking at 2x squared over x squared. Well, if I simplify that, I just get 2. That means if I plug infinity into this, I just get 2. If I plug in negative infinity, I'm just going to get 2. So the horizontal asymptote is at y equals 2. We do have one, which is nice. We can graph that. All right, now let's do a sine analysis around those things. So I got -3/2, -2. So -2, -3/2, and I guess 4 are my ones. I'm not going to change signs at 4. I know that because it's a hole, and my hole's located here. So if I plugged in values, positive, 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 like 5, I got positive. If I plug in something like 0, positive, negative, negative, positive, that's going to be a positive. At negative, I mean, I have to plug in like -1.75, but it'd be like, this will end up being negative, 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 positive. So negative, negative is a positive, negative, positive is a negative, positive over a negative, negative. They do change signs. Again, you can look at the multiplicity. There's no squared over any of these. Before there is 2 of them, so that's like an indication of the multiplicity being 2, so you're not going to change sign. But the other ones, it's like to the first of the first, so signs are going to change. You can always check. So what is that telling me? That is telling me that I'm going to be approaching this horizontal line, but to the left of -2, I'm going to be on the positive side of things. Now, there are situations where you can go like below and then kind of come back up, but most likely, usually with horizontal asymptotes, if we're starting on the positive side of things, like to the left of this asymptote, I'm at the positive side of things, and then I'll just be approaching this here. Now to the right of my asymptote at -2, I'm at the negative side of things. So if I'm approaching a vertical asymptote, I'm going to be starting right here. I'm going to be passing through my x-intercept at -1.5. I'll pass through my y-intercept here. I will pass through my hole here, and I'll be trending in that direction. And this is what your graph is going to look like. And if you're doing your homework, you can check so that you have some confidence. You got 2x squared. We have -5x. We got -12. Okay, there we go. And then we have x squared minus 2x minus 8. Yep, right on the money. -2, vertical asymptote, going down, coming through this here, hitting through that point there. And at 4, we have a hole. Where is its location? It ends up being at 11/6. All right. Space for scratch work. Thanks. All right, let's do this. So, x-intercept, vertical asymptote, hole. Those are all from the zeros. Y-intercept, horizontal asymptote, sine analysis. All right, let's factor. I got x plus 1 over. Factor out an x. I got x squared minus 2x minus 3. So this can be x plus 1 over x, x minus 3x plus 1. Two numbers that multiply to get -3 and add to get -2. And away we go. So no x-intercept. There's no numerator that equals 0, because if I plug in -1, I got that 0 over 0. That's an indication of your hole at -1. Okay. I do have vertical asymptotes, which will be a number over 0 at 0 and 3. My x-intercept when x is 0, well, that's a vertical asymptote, so there is no, there's no x-intercept because I have a hole at 0. There's no kind of 0 over a number. So I'm saying there's none. None will be typed in shortly. There we go. The y-intercept when x is 0, I'm going to plug in 0 in for h, and I get 1 over 0 again. You have a vertical asymptote at 0, so there's no y-intercept. You can't do it. You're going to have a number over 0. Horizontal asymptote. Okay, you're plugging in infinity. This stuff is going to be like adding small decimals to very large numbers. We're just going to look at x over x cubed. Well, that simplifies to be 1 over x squared. If I plug in positive or negative infinity, it's 1 over a very, very large number. That's going to be approaching 0. Both directions approaching 0. So what do I have here? I have a vertical asymptote at x equals 0. I have a vertical asymptote at x equals 3. I have a horizontal asymptote at y equals 0. I have a hole at -1. And let's find the location of that hole. If this canceled out and I plugged in -1, I'd have 1 over -1 times -4. So that's 1/4. So -1, 1/4. Plugging in -1 into this. I feel like I'm missing something, but let's find out. Okay, sine analysis around -1, 0, and 3. I'll show you what's going to happen. Let's plug in something like 4. Positive, 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 positive. Vertical asymptote, most likely signs change. Let's see. If I plug in 2, positive, positive, negative, positive. Okay, so signs change here. We got negative. Okay, at 0, I have another vertical asymptote. So what's going to happen is like I'm going to be negative, but not cross the x-axis, and I'm just going to be negative stays negative. Because I'm going to have to approach these asymptotes from both directions. So like figure out the sign. If it's positive then negative, like I'd have another 0 here. But I'm not crossing the x-axis, so you'll see what I mean by that. Okay, going to the left of 0, like negative a half, positive, negative, negative, positive. So positive, negative, negative, positive is a positive. So I'm going to be coming from the positive side of things. I'm going to go through my hole, but I'll see that I'm going to stay positive. Again, I don't cross through the x-axis. I know that. I don't have any x-intercepts. Plug in something like -3, negative, 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 negative. That ends up being a positive. It's 4 negatives. So watch what it's going to be. Okay. Let's see. To the right of my vertical asymptote, I got positive to the right. So I'm going to be approaching positive infinity from there. And then as I go off to the distance towards infinity, I'm approaching y equals 0. But then to the left of 3, I'm going to be in the negative land. Now I'm approaching the vertical asymptote, so it'll be going towards infinity. It'll be a number divided by something very, very small, but negative. And I can see that I'm going to be like this, negative values. But what do? Well, I got to go back towards the negative values. You can see where like the maximum would be. Maybe you could like plug in a point just to kind of help. But right now, we don't really care where that max is. Just kind of know that it's going to look like this. And then to the left of 0, I'm positive. I'm positive. So I'm going to be up towards positive infinity, passing through my hole, and then going towards my horizontal asymptote of y equals 0. So this is what this graph would look like. Any questions? Yeah. How do I know where the graph is going? This part or the graphing part? So I kind of use all my information. Like I know of a vertical asymptote. If I have a vertical asymptote, no matter where my vertical asymptote is, I got to be like going close to it towards an infinity, right? Well, if I know the signs of my values, like let's look at the vertical asymptote at 3. Just froze on me. Okay, vertical asymptote at 3. Well, let's look at 3. Well, to the right of 3, I have positive values, kind of doing the inequalities. Well, positive values to the right of 3, since this is a vertical asymptote, must mean we are towards positive infinity. So that is one piece of information I use to kind of know that I'm starting here. Now, where do I go? Well, I know I have a horizontal asymptote at y equals 0. So that means I have to end here. What do? I just kind of connect those two kind of arrows. So it's almost like I'm starting with the arrows and then I'm connecting. So let's talk about here. To the left of 3, I'm at the negative values. So it's a vertical asymptote, so that means I need to be going towards infinity, towards the asymptote, but getting very close to it. So we got this. And then I have at 0, another vertical asymptote. Well, to the right of 0, I have negative values. So that means I must be going towards negative infinity there. So just like start with just some arrows. Now my horizontal asymptote's y equals 0, so I got this arrow here, and that means if I go all the way to the left, I have this arrow here. I got that arrow, that arrow, that arrow, this arrow. And then again, my other vertical asymptote is at 0. To the left of 0, I have positives, so that means to the left of this vertical asymptote, I'm at the positive side of infinity, going towards it. Okay? This is how we approach asymptotes. It's got to be very, very close to positive or negatives. If you kind of understand those arrows, you can connect them. And then make sure if you have any other locations like this hole, you connect those. Okay? Let's try the next one. Yeah? Yes, that's from the vertical asymptote, the holes and the zeros. This is like if I asked you to solve the inequality, when is this bigger than or equal to 0? We found all the zeros when the numerator equals 0, when the denominator equals 0, by factoring the numerator and the denominator. Then we found all of these zeros. We plot those zeros down, did the sign analysis. If I asked this question, you would say, okay, this interval, this interval, this interval, when the values are positive. Okay, let's do another one. So, I don't know, you want to let's just factor first. The top can't be factored, the bottom can. It's x plus 2, x minus 2. Slow down. All right, so top equals 0, that's an x-intercept. X-intercept when I have a 0 over a number. So I got 1/2. Vertical asymptote when I have a number over 0. So -2, +2. Holes, there are none. There are no zeros over zeros in my function. What's next? Y-intercept, I can figure out this. Y-intercept is when x is 0. So f of 0, I plug in 0 for x. I get -1/4. All right, so I got 0, -1/4. I got a vertical asymptote at +2 and -2. I'll just do the arrow kind of technique this way. X-intercept at 1/2. Okay, so I got this y-intercept, I got this thing. Horizontal asymptote, look at the biggest degree terms. The 1 is like adding a very small decimal. The 4 is like adding a very small decimal. I get -2x over x squared. It simplifies to be -2 over x. If I plug in infinity or negative infinity, it'd be a number divided by something infinitely large, turns into something infinitely small, goes to 0. So y equals 0. Okay, remember horizontal asymptote is when I'm plugging in infinity or negative infinity for x. I'm looking at what's going on all the way over here to the left and all the way over here to the right. I'll do a sign analysis around my zeros and my, all of my zeros really. Just whenever I got a 0, numerator, denominator, throw it down there. So -2, 1/2, and 2. Let's see. Plug it into the factored form. 3. I'll have a negative in the numerator. Positive, positive. Plug in something like 1. I'll have a negative again in the numerator. But then I'll have a positive and a negative in the denominator. So we're going to change signs at 1. Plug in something like 0, positive, positive, negative. So that's going to be a negative. -3, it's going to be a positive in the numerator. -2 times -3 is a positive, plus 1 is a positive. So positive, negative, negative. So that would be a positive. So we change sign at all these locations. All right, now let's throw down some arrows. Horizontal asymptote. So as x goes to the right, I'm approaching y equals 0. From the negative side of things, so I should probably not just be like, I should probably be on the negative side of things, like here. But it's not a huge deal actually for you guys. That means over here towards negative infinity, I'm going to be approaching 0 as well, but probably from the positive side of things here. Look at my vertical asymptote. So -2. To the left of -2, I'm in the positive land. So I'm going to be coming from here to the left of -2. To the right of -2, I've got negative land. The next 0, okay, that's fine. Let's look at the next vertical asymptote at 2. To the left of 2, I'm up here towards the positives. To the right of 2, I'm in the negatives. All right, if you got that, then you know where the graph looks like. We're going to be here to there, here going through my 0, going through my x-intercept, my y-intercept, going through here, and then I'm coming from here like that. Yeah, just plug in a test point in your interval to help determine whether your function is positive or negative. Okay. Let's check that. Let's double check the last two, actually. X plus 1 over x plus 1 over x cubed minus 2x squared minus 3x. There we go. Exactly what I have. And I have a hole at -1. Or is it the hole? The hole is at -1/4. What is the H? The horizontal asymptote, H? There you go. In the halfway formula. Oh, the H is the amount of time it takes to get to half. Yeah, so H is like the amount of days it takes to have. No, or day, whatever the time is. This one, 2x minus plus 1 over x squared minus 4. There we go. Exactly what I have. Negative towards y equals 0. We're passing through 0.50. There's my other 0, -1/4. And then here's my other one right here. All right, right on the money. All right, let's see this guy. I can factor the numerator to be x plus 1, x minus 1. Denominator stays as x. So x-intercept, when the numerator equals 0, is at -1 and 1. This is when I have a 0 over a number. My y-intercept, I'll do later. Let's do the vertical asymptotes. You have a vertical asymptote where you have a number over 0. That's going to be at x equals 0. I do not have any holes because I'll never have a 0 over 0. We can find my y-intercept when x is 0. R of 0, plug in 0 here. Does not exist because I have a vertical asymptote at x equals 0. I have -1 over 0. Horizontal asymptote. Okay, this is important. The -1 we can ignore, and we'd have x squared over x. Well, this would simplify just be x. Now, it's when you get this that it's important to realize, like, if this was something else, like if this was -3, and I'd simplify it'd be -3x, you got to be careful. Like, as x approaches positive infinity, if it was -3x, it would be -3 times positive infinity. That'd be negative infinity. A negative times a positive is a negative. I don't have that, so it works out nicely, but you got to be careful with these horizontal asymptotes when you're talking about infinities, because it could change depending on the direction. It's not always going to be positive, positive, and negative, negative. In this situation, it is. Because if I plug in infinity to here, I get positive infinity. If I plug in negative, I get negative infinity. So there is no horizontal asymptote. And just double check to see, like, as I'm going to the right, I'm going to the positive land. If I'm going to the left, I'm going to the negative land. All right. Sine analysis around my zeros at -1, 0, and 1. So, I don't know. Let's go back down here. 2, positive, positive, positive. A half, positive, negative, positive. Negative a half. Positive, negative, negative, negative 2, negative, negative, negative. And you just got to remember, like, a negative times a negative is a positive. If you got 3 negatives, you got a positive times a negative. That's a negative. You could also use multiplicities, whatever you want to do. All right, so vertical asymptote at x equals 0, a 0 at 1, a 0 at negative 1. As I am to the right of 0, I'm in the negative land. So that means I'm going to be going towards negative infinity. If I'm to the left of 0, I'm in positive land. So I'm going to be going towards positive infinity. So what am I going to look like? Something like this. If I connect the arrows and our dots. X squared minus 1 over x. There you go. On the money. All right. Nothing to factor, so I can just look and see. X-intercept, 0 over a number, negative 1. Vertical asymptote, number over 0, 3. Holes, none. There's no 0 over 0. Y-intercept, when x is 0, plug in 0 for x. I get 1 over negative 3 squared, which is 1/9. That's great. So, and then horizontal asymptote. This one's a little tricky. I could cancel this 3. That 3 will be nothing when I'm plugging in infinity. This 1 is just kind of forget about it. So I have x over really x squared. That's not bad. That simplifies to be 1 over x. If I plugged in something like infinity, I'd have a number divided by infinity, which is approaching 0. So y equals 0. Again, horizontal asymptote, you are thinking about plugging in positive and negative infinity in for x. All right, and let's do some signs. I got negative 1 and 3. The multiplicities are not just 1. Watch what's going to happen at 3. So to the right of 3, like 4, positive, positive squared, positive. In between these, like 0, positive. 0 minus 3 is a negative, but I'm squaring it. It's a positive. So that's going to be a positive. I don't change sign. How can you tell you're not going to change sign? Well, check or look at the multiplicity. Multiplicity 2 means it's a bounce. Then negative 3, negative. This is a positive, so this is a negative. All right, so throwing those together, let's do some arrows. I have a horizontal asymptote at 0, coming from the positive side and probably approaching 0 from the negative side of things. I have a vertical asymptote at 3, so here's 3. To the right of 3, I'm going from the positive side of things towards infinity. To the left of 3, I'm coming from the positive side of things. I have a y-intercept at 0, 1/9. And I have an x-intercept at negative 1. Ooh, this is interesting. So I bet you it looks like this. We can connect this, we stay positive values. I know we stay positive values. But here it looks like I'm going to be going through, but I don't have another vertical asymptote. So it's just like going through, but then we'll come back up towards y equals 0. So it is a situation I kind of told you about earlier where sometimes you kind of go underneath and then come back up. I think that's what's going to happen here. So I think I'm going to go through here. I'll end up going through, but then trend back up towards y equals 0, which is my horizontal asymptote. But there'll be negative values. Well, let's see. X plus 1, x minus 3 squared. Oh, hold on. This is a good one. X over x. What does it look like? Just 1, right? Aha, hold on. Good 0. Undefined. You can't have 0 over 0. Where is its location? Well, you can cancel. You just get 1. Anyways, x plus 1 over x minus 3 squared. Yeah, right on the money, right? We're going towards infinity, going towards 0. Infinity, 0. We go through, but we're coming back towards 0. How are we doing? Yeah. There isn't one. So what I did is I simplified the x squared over the x, which is x. And I think about plugging in infinity into x. If I plug in infinity, I get infinity. If I plug in negative infinity, I get negative infinity. Now, if I ask you, is there a horizontal asymptote? Because you're not getting a number, you would say no. Okay. But really, we're not really kind of stressing about like the horizontal asymptote. We're really just kind of, I could write instead of HA, I could write N behavior. You could say like what's going on to the right and what's going on to the left. Okay. Write a function rule for h of x. Well, this is not fun. All right, let's see. I got a vertical asymptote at negative 2 and 2. So x minus 2, x plus 2 has got to be in the denominator. I don't have any x-intercepts, but I do have one at 0. I'm thinking that's going to be the case. I do have a horizontal asymptote at 1. So let's think. If this was x over x squared minus 4, I would not have a horizontal asymptote at 1 because I would have a situation of it'd be 1 over x, which simplifies to be 0. If it was x squared over x squared, then this would simplify to be 1 if I just ignored the negative 4. I'm going to go with this. I feel pretty good about this, but let's find out. X squared over, what was I? X squared over x squared minus 4. There we go. Okay, how did I do that? Let's just walk through how I did that. I kind of figured out, okay, vertical asymptote negative 2 and 2. So that means in the denominator of my my rational function, so 2 means x minus 2 must be in the denominator. Negative 2 means x plus 2 must be in the denominator. I have a 0 at 0, which means like x needs to be there. Okay, so I start with that. Maybe I then distribute things, and this simplifies to be x squared minus 4. But then I realize I have a horizontal asymptote at 1, which means if I plugged in infinity and I cross off the 4, this can't be it because x over x squared simplifies to be 1 over x, which would, if you plug in infinity, go towards 0. I want it to go towards 1, which is why I changed this to an x squared, so that it's x squared over x squared, which simplifies to just be 1. Okay, now, same thing, but I have a hole at x equals 3. Well, to have a hole, you just need a 0 over a 0. Okay, watch that. If I plug that in, it's not gonna, and maybe they want you to distribute this, and maybe not. I don't know. Let's distribute it anyways. You get x cubed minus 3x squared over, this is x cubed. I think we all have different terms every time. So x cubed minus 3x squared minus 4x plus 12. Watch. Because I'd have a 0 over 0, like it would be the same thing. Y equals x cubed minus 3x squared quantity divided by x cubed minus 3x squared minus 4x plus 12. There we go. They're on top of each other. If I hid this, it's there, but at 3, this guy doesn't have a function value. This guy does. Okay. This should be a 4x. This is just like review. We got zeros at 0, 4, negative 3. Let's just do some signs here. It's probably easier than to try to like distribute everything out. You can tell this is going to be an x squared, x cubed, 4, 5, 6, x to the 6th, but a negative leading coefficient. You should do some sign analysis here. Oh, you also have 0 as a 0. Plug in something like 5. It's 5 squared, but it's a negative. So plug in something 5. You got negative times. This is a positive, and this is a positive. So I'm going to be down here. Passing through 4, plug in something like 1, negative, negative, positive. So that's a positive. So I'm in the positive land. I'm going to bounce off at 2. I'm going to bend through at negative 3 just by remembering some things. I'll look like that. My leading term is negative 1. My x-intercepts are at negative 3, 0, and 4. My y-intercept is at 0. That's when x is 0. End behavior, both towards negative infinity. It's an x to the 6th power, even power, negative leading coefficient, down and down. This is 1, 2, 3, 4, 5, 6. This is also a 6th power, but the leading term is a 1. X-intercept would be at negative 5, 2, and negative 3. Bounce off negative 3, bounce off at 2. Y-intercept's at 0, not at 0. Hold on. If I plugged in 0, g of 0 would be 5 times 4 times 9. So what's that? A big number? 20 times 9? 180. Yep. That's great. So x to the 6, you could also do a sign check. Plug in 4, positive, positive, positive. Bounce off of 2. Pass through 180. Bounce off of negative 3. Oh, yeah. I'm not going to, it's not x to the 6th. It's x to the 5th. Pass through negative 5. End behavior. X goes to infinity. G of x is going to go to positive infinity. X goes to negative infinity. G of x goes to negative infinity. I don't know why these are in this lesson. It's more just like sketching. All right, that's it. Good luck out there, team.